Hello everybody. In this presentation, I'm going to talk about diffraction. First of all, I will talk about Werner and Fraunhofer diffraction, then compare them together and take a look at MATLAB code. At the end, we will see what's going on in experimental setup. What is diffraction? According to Huygens' principle, waves spread out after the path through a slit. This spreading of light from initial line of travel is called diffraction. Diffracting structure depend on several factors, such as geometry. Geometry includes size of aperture and shape. Independent of geometry, wavelength of incident radiation, shape of incident wavefront, and the distance at which an observation screen is placed from the diffracting structure will affect the pattern. We have two types of diffraction, Werner and Fraunhofer diffraction. Let's go to Werner diffraction. The left side is a general configuration of Werner diffraction. Or near-field diffraction is a process diffraction happen when wave pass through an aperture and diffracted in the near field, causing any diffraction pattern observed to differ in size and shape depending on distance between the aperture and projection. This is aperture and projection. It occurs due to the short distance in which the diffracted wave propagates, which results in a Fresnel number greater than 1. Assume that a wavelength is lambda and the phase is shown by this relation. Light originates from a S point and reaching the target on the right side. And intensity is given by this equation. Fresnel integral has two functions, S and C, which is defined by these two functions, and this equation gives us intensity. The right side is a plot of Fresnel integral, which C and S is shown in this plotting. They are different diffraction pattern of Fresnel diffraction. For wire, straight edge, circular, rectangular, and triangle. Okay, let's talk about Fraunhofer diffraction. Fraunhofer diffraction occurs in the limit of a small Fresnel number. In Fraunhofer diffraction, the diffraction pattern is independent of distance to the screen, depending only on the angle to the screen from the aperture, this angle theta. And the right side is a diffraction pattern of single slit, which was photographed with a helium neon laser and a micrometer controlled single slit. Fraunhofer diffraction or far field diffraction occur when this relation happens. And equation of this diffraction is given by this, which in this equation, which is C is constant, K is wave number, and R is the distance from the aperture to the projection. And the integral is taken over the aperture. For intensity equation, the geometry, consider this geometry. Assume that the slit is ray line, this slit. In the direction perpendicular to the page, so we can neglect diffraction effect in the perpendicular direction. Light diffracted by a line slit and produce irradiance at point P in the direction with an angle theta, which electric field measured by this and irradiance at point P is given by this relation. They are diffraction pattern for multiple slit, rectangular, and square aperture. For in multiple slit, the irradiance at point P from this diffraction pattern is given by the product of the diffraction pattern from single slit and the interference pattern from a multi-slit. In fact, this is combination between diffraction and interference. This table characterizes the difference between Ferner and Fraunhofer diffraction. I talked about a description of these two diffraction, and the difference between two diffraction are in observation distance. For example, for Ferner diffraction, a screen placed at finite distance from an object, but for Fraunhofer is located in infinite. Surface of calculation for Ferner is spherical, but for Fraunhofer is flat surface. Movement of diffraction pattern for Ferner align the corresponding shift in the object, but for Ferner fixed. Position will fixed. Diffraction pattern for Fraunhofer. In diffraction pattern for Fraunhofer, shape and intensity remain constant. But for Ferner, change depending on wave propagation. Wavefront for Fraunhofer is planar wave, and for Ferner is cylindrical. Source and screen for Ferner and also for Fraunhofer, both far away from each other. Incident wavefront for Ferner are spherical, but for Fraunhofer is plane. MATLAB is a powerful tool for calculating diffraction pattern. By using this code, I can calculate both intensity and two-dimensional wavefront. This is the function and symbol that was used in the following MATLAB code. First of all, I brought single-slit diffraction pattern for far field with different Ferner number. This is for near field for Ferner number from 1 to 16, and the very near field Ferner number are 10, 100, and 1000. As the Ferner increase, the peak or the signal will increase between two main peaks. This video shows diffraction pattern with different Ferner number. This code is about circular aperture for Ferner. The right side shows us Ferner diffraction pattern and intensity. This is a square aperture with different Ferner number. and far-field diffraction using Fourier transform for single slit. It's again in this code I also again use different Ferner number. And the last one is Fraunhofer diffraction of circular aperture. In this in this pattern, a bright central region is known as airy disk, and series of concentric rings which surround the airy disk is called airy pattern. Okay, let's talk about experimental setup. In this setup, I use laser, which is coherent and monochromatic with circular aperture, which has variable size, and observation screen, which give us the pattern. This setup is used to test the validity of calculation for computer simulation and experiments data. In each case, F is Ferner number. Each figure shows the simulated field on the left and the real diffracted field on the right. It can be seen from the images simulated field almost close to those observed in the lab with the same parameter. Despite some small inconsistency between the real and simulated case, the computer model appeared to work well. The main goal of this presentation was diffraction. Diffraction means the slight bending of light. And we found out that we have two types of diffraction, Fraunhofer and Ferner diffraction. Okay, thank you for listening.